Hello and welcome to the right angle. In this video we are going to really handle one of the basic core topics of geometry. This is the first topic you need to know well, and this is going to be a lecture. As you know, this channel is for those children in middle school who would like to be comfortable with maths, not worry too much, and also get good at it while having a little bit of fun, maybe enjoying it. But for that, you need to know some basics, and one of the basics in geometry is the idea of parallel lines, and along with it comes an understanding of angles. That is what we're going to handle today. Knowing what a straight line is, consider a straight line here, and if you have, let's say, another line, and that's, let's say, represented by this blue pen, if I place this right on top of it, yes, like this, it means this pen is making no angle with this line. That is, it is having 0 degrees. Angles are measured in degrees, and a little later you will learn that they can also be measured in something called radians. That's a different way of thinking about it. But a simple way to think about angles is measure them in degrees, and we hold a certain convention for that. So basically what it means is we just assume that a certain fixed angle is so much, and we measure all other angles in proportion or in relation to this, in proportion. An idea that was taught earlier in lower classes. We use that all the time. So, a couple of things here. So what we do is, if we extend this line this way, okay, so let's just do it very quickly and maybe not very accurately. If we extend this line in the same direction, in the same basically orientation. I'm just using different words, but basically what we're saying is this line came up till here and we extended. Okay, then around this point that you see, we say that this angle is 180 degrees, and why 180? This was alluded to or referred to in an earlier video in which I talked about what's so great about the number 12. Number 12 can be shared or divided easily by so many other numbers, but for angles, people wanted a finer division than just saying, oh, this is 12 degrees, because angles are very important. You see, most of geometry and the first uses of geometry were around navigation. Of course, one was also about constructing buildings. There geometry is very important, but also in navigation. In navigation, if you get the direction wrong, it's actually dangerous. So this is 180. So 180 is a multiple of 12. So 12, and you'd also like, so 12 can be shared into by 2 people, by 3 people, by 4 people, by 6 people, or 6 ways. But you also would like sharing in terms of 5. So 12 into 5 is 60. But we don't say this is 60 degrees, we say it's 180 degrees because we wanted finer divisions. So the convention was this is 180 degrees. And if you go halfway, that's called 90 degrees, also a right angle. Of course, you're going to learn about right angles in the right angle. That's the name of this channel. In any case, this is 180. And the way it can look is, I'll just try to show you. We just know that a square, let's take a square, the corners of a square are 90 degrees. So this is 90 degrees. So if you have this is 90 degrees, what happens if you take this square and rotate it by 90 degrees? What happens to this? So fortunately I got another you see that? So let me place this here on top of this line. And right now I'm placing it right on top of that. Not very precisely, but that's so this is 90 degrees. And if I turn this, take this out and turn the square such that this edge goes and lines up with this edge, that means I have rotated about this point, I have rotated by 90 degrees. I left a little bit of space, and you see this has joined up on this line. Yeah, so and that's 90 degrees too. So if you got a perfect square or a good rectangle, each of the corners is 90 degrees. Basically, it is half of that of an angle that a straight line would make at any point on the straight line. So if you rotate something by 180 degrees, that means you're turning exactly the opposite way. So if you're walking in some direction and you turn not a few degrees, not some number of degrees, but 180 degrees, then you're going right back. That's, you could say it's a U-turn, right? So here, this 290 degrees make 180 degrees. So taking these out, you have this as 90 degrees. And the other thing is, if you take another line and put it right on top, that's 0 degrees, and as you move it, this angle here, it is increasing, and when it is directly vertical, assuming this is horizontal, when it is straight up, then this angle is 90 degrees. A little bit of repetition, but you just need to get the idea. And also 90 degrees is a very important angle because, you know, suppose you can imagine sun at the noon time and you're standing straight, or a pole or something straight is standing vertically, it will cast no shadow on a horizontal ground. So the important angles are, of course, 90 degrees, 180 degrees, 60 degrees, 45 degrees and 30 degrees. In fact, 45 degree and with 90 degree, we have seen this in an earlier video, and this is like a set square. So I've shown you this before. It's basically, if you got a perfect square and you fold the two corners, opposite corners, you make a diagonal and fold it. This is 90 degrees, remember? And these two together, each of them is 45 degrees. So you get this. You have that as a set square, right? And the other set square you have in your geometry box involves 60 degrees and 30 degrees with a 90 degrees. So these are the important angles you are supposed to just know. And they keep coming back in geometry time and time again. Now about parallel lines, that's an interesting topic all by itself. In parallel lines, it is just like as though there's one line and there's another line right on top, but then it's shifted exactly in the same direction, without changing its direction. It is shifted like this. So here you have two parallel lines in green, and this line you may not be able to see it very easily, but this line where I have marked an angle here, this is perpendicular. This line joins these two parallel lines, and there will be a distance, right? There will be a distance here. Now the thing is, if you draw from any point, if you draw a vertical or a line which is perpendicular to this line, which meets the other parallel line, then that distance will be exactly the same as this distance. So in fact, that's true even for any arbitrary angle. If you have a line at some angle, this distance, or in this case, let us call this A, and let's call this A dash. So A to A dash will be the same if this black line is moved in parallel anywhere. So wherever this black line with the same angle, whatever this angle is, okay, let's call this angle, I don't know, let's call this angle just theta. These Greek letters are sometimes used, but let's call this angle theta. So this line, if it is moved alongside, keeping this direction theta to the parallel line, anywhere you take it, those 2 points will have the same distance as A and A dash. This is an important property of parallel lines. We will discuss more about parallel lines a little later, maybe in the next video. I hope you understood this. There was, of course, a couple of ideas about angles, and I hope you understood them, and about parallel lines. There is more to discuss on parallel lines and angles, and these will all show up by and by. I hope you understood all that. Thanks for watching. Don't forget to like, and I shall see you again quite soon.